9b. Do you remember the topic for the 9a? What was the topic for the lesson 9a? Yeah, so exactly the same thing. Exponential function. Okay, that's why I wrote part 2. So last time we learned how to wrap something like this: y equal to 2x plus 1. Correct? Do you remember what is the step by step? What is the step by step? What is it called? Horizontal asymptote. Very good. Let's give me 1 point. First, you're gonna identify the horizontal asymptote, right? Now, Alex, next, what is the second step? T-table. What point? What number? What value? Okay, now I'm gonna have another question for you. So give Alex 1 point too. This is the HA. Okay. Next question. 0, -1, and 1. I told you you need to get those 3 points, right? What is the reason? Why I specifically tell you you should get the -1, 0, and 1? Because that's directly on the curve. Show the characteristic of the graph. If you get on a number, it's maybe along the end point, and that you cannot see where the curve. Okay, give me 1 point. Next question. We want -1, 0, and 1. We want it for the x, or we want it for the power. We say it for the x. Like you only want x to be -1, 0, and 1. Okay, all right, have 2. Okay, 3, 4. Okay, now who say we want the power to be -1, 0, and 1? Not the x, but the whole power. Raise your hand. All right, just stand your ground. Let's give Amy 1 point. Yeah, you should stand your ground. We want the power, not the x. Okay, but the rest of the example we did on the 9a, we only have the x. But today, for example, you're gonna have something like this: 2x minus 2 plus 1. Now we want the whole power to be -1, 0, and 1. Okay, make sense? So that's the point for this today lesson. Okay, let's finish this. We review this one. So because the power only have x, that's why I'm gonna choose what point is this here? -1, 0, and 1. Very good. Okay. Now to plug it in, 2 to the power -1. What is 2 to the power -1? 1/2. Yeah. Let me use call. So I'm gonna call everyone, not just one person answer all of them. All right, I'm gonna use call. Okay. Now Adam, help me to plug it in the 0. Easy. Oh, that's fast. Okay. 2 to the power 0 is everything to the power 0 is 1. So 1 plus 1 is 2. Good. 1 point for Adam. Help me to plug it in the 1. Easy. Emily. So easy. Plug it in 1. What do you have? 3, right? 2 to the power 1 is 2. 2 plus 1 is 3. Very good. 1 point for Emily. Now, just plug it in. See, literally just only 2 steps. Okay? HA and T-table. Why we need to draw the HA? What's special about the HA? What's special about horizontal asymptote? Huh? Yes, you cannot. You can for the algebra 2 right now. You cannot go through it. Yes, that's like a ground. You cannot go lower that or then cross over that. Okay, but later on if you go calculus, yes, sometimes they can cut it, but it's fine. Give just me 1 point. Okay. -1 and 1.5. This is 1.5. Okay. This is the only situation that I recommend you to do the decimal place. Remember, I always tell you to don't do decimal place because it's not correct. It's not exact the value. But in the T-table, yes, maybe you can do the decimal place because you know exactly where it is on the graph. Make sense? So -1, -1, 1.5. This is 1, so 1.5 will be here. All right, 0, 2, 0, 1, 2. And 1, 3, 1, 3. Okay? Make it like this. Make it a curve. Okay? And again, don't do like this. This is going to be wrong. This is a parabola. Okay? Why they don't be like this? Do you remember why we stop like this? In what case we stop right here? Remember the lesson? Remember we learned about how to wrap this one, the square root? Inside square root cannot be negative. That's why they cannot extend this endpoint. But this one, there's no domain. Domain is everything. There's no fraction, there's no square root. So remember to keep extending these two ends. That's what I mean. Okay? It needs to keep going. There's no stop. That's it. That's what we did. What we did for the 9A. Now 9B is something you see on the power, not only the x. Okay? You have something else. Where is the HA? 1. It's still 1. It's plus 1. That means it's still 1. So what does it mean 1? X minus 1, x equal to 1 or y equal to 1? What do you mean 1? X equal to 1 or y equal to 1? We already did it. X equal to 1. I just want to clarify, okay? Because horizontal is the x. So x equal to 1. Wait, what? Y equal to 1. My bad. Y equal to 1. Because the horizontal. The horizontal is y right here. X, it should be right here. X1, even though this is the x-axis, but x equal to 1 is this line. You got to pass the x equal to 1. So it should be the y. Well, if you, at least you need to do something that I know that you know where is it. Yeah. At least you write, maybe you got to write 1 here. It's still okay. Yeah. Good question. Okay, now, what value of the x I plug it in here? That's the difference between 9A and 9B. What value? Let me try it. The whole thing and the power is the same. What do you mean? You mean the x or the power, right? All right, let me call. Ruby, what value should I plug it in here? That's the difference. We don't want we don't want the x to be negative 1, 0, and 1, but we want the power. Okay, the power, that's mean the whole thing here. We want this whole thing here, negative 1, 0, and 1. All right, so what value of the x? So that when I plug it in here, I'm going to get negative 1. 1, okay? Now, what value of the x? So that I'm going to get 0 out. 0 minus 2 is 0? 2. 2 minus 2 is 0, okay? What number of the x? So that when I plug it in here, I'm going to get 1 out. What minus 1 is 1? 3. Oh, what minus 2 is 1? Yeah, 3. 3 minus 2 is 1. Make sense? So again, I want to emphasize again. Negative 1, 0, and 1 is what we want for the power, the whole power, not the x, okay? So we need to find what value of the x so that the power is negative 1, 0, and 1. If you don't know how, to find this number, just do this. Maybe you can just let them equal to negative 1, let the power equal to negative 1, and you're going to solve for the x. How are we going to solve this? Plus 2, right? So x equal to 1. That's how you find 1. Now let's say if you cannot do a mental map or it's complicated, you cannot guess. Okay? So let them equal to the value you want. Like I want it to be 0. Let it equal to 0 and solve for it. Plus 2, plus 2. So x equal to 2. X equal to 2. Same thing for the 1. I want this one to be 1. I add 2, add 2. This gone. 1 plus 2 is 3. That's how I know this is going to be 3. Make sense? All right. Now plug it in easier as well. Because we purposely make the power to be negative 1. So when you write this, you don't need to plug it in. That's the shortcut. You know what I mean? You can just put this one equal to negative 1. Why? Because we want the power to be negative 1. That's why we found x equal to 1. So you don't need to plug it in 1 there. You just know that the power is going to be negative 1. But if you don't know, if you're not sure what I'm talking about, just plug in normally. Okay. 1 minus 2 plus 1. So 2 to negative 1 plus 2 plus 1. 2 to negative 1 is 1 half. 1 half plus 1 is 1.5. Okay. So this is if you don't know like what the power of equal to eventually. But again, we purposely choose the 2 because it's going to make the power equal to 0. So no, this one for sure equal to 0. I know this one for sure is 1. Okay. 2 to the power 0 is 1. 1 plus 1 is 2. They're actually just the same as the assemble 1 we did over there. Okay. This is going to be 3. Okay. 1, 1.5. This is 1. This is 1.5 maybe around here. 2, 2. So 2, 2, 3, 3. Sound good? Assemble 3. So everyone get the middle whiteboard too. We're gonna do middle whiteboard later. There are 6 assemble. Maybe I'm gonna do the first 3. You're gonna do the last 3. All right. Okay, where is the horizontal asymptote? 4. X equal to 4 or Y equal to 4? It's the horizontal line. It's Y, okay? 1, 2, 3, 4. All right, now what point, what value you're gonna choose for the X so that the power going to be negative 1? Negative 1 half, okay? Again, if you cannot know what number is this, just let the whole power equal to negative 1 because that's what you want, right? And then you're going to solve for x divided by 2, x equal to negative 1 half. That's how you know it's going to be negative 1 half, okay? Negative 1 half. What number so that the power going to be 0? Easy. 0, right? 0 times 2 is 0. What number you're going to plug it in? You have 1 half. I mean, I just said the answer. What number you plug it in, you're going to have 1. All right. Okay, plug it in. Again, I know for sure the power going to be negative 1 because I purposely chose this number because I know it's going to be negative 1. Okay, so I just write negative 1 here. Plus 4. What is 3 to the power negative 1? Negative 3. Thank you, Amy. I'm almost fainted. Negative power, what does it mean? Mistress? Huh? 1/3. 1/3 plus 4 is, so it's about 4.3. 4.33. Because 1 over 3 is 0.323, right? Again, in this T table, I recommend this is the only case you should do the decimal place because you know where is it on the graph. Okay. Other than that, don't use the decimal place. It's usually not going to give you like exact value. All right, 0. So 3 to the power 0 is 0. 3 to the power 0 is 1. I'm testing you. 1 plus 4. 1 point up, Mr. Lee. Yeah. 1 plus 4 is 5. And again, I know for sure it's going to be 1 because I purposely chose this value so that the power is 1. So I just write 1 here. 3 to the power 1 is 3. 3 plus 4 is 7. Okay. So I have negative 1 half. Negative 1 half here. And 4.3. So this is 4. So 4 to be around here. All right. 0 and 5. 0. This is 4. So 5 will be around here. 1 half 7. 1 half here. So maybe this is 7 right here. Yeah. Easy, right? Easy, right? All right. So the last 3 you're going to do on a middle whiteboard. Okay. Maybe just 2. Just 2 more. Yeah. And then we're going to do the aspect. We're going to review the aspect. Melanie, I'm going to help you out here, okay? Where is the HA? Where is the horizontal asymptote? 1, right? This is indicate like what is your, where's your horizontal asymptote? Plus 1, that means go up by 1. Negative 2, that means go down by 2. It's nothing, that means it's right on the axis. So y equal to 1. This is the HA. All right, what number when you plug it in here, you get the power equal to negative 1? What number? So again, if you don't know, you just let the whole thing here equal to the value we want. The value we want is negative 1, right? So let them equal to negative 1. How are we going to solve this? Add 3, negative x equal to 2. And divided by negative 1. So this becomes positive 1. 2 divided by negative 1 is negative 2. Okay? That's how you know what number you're going to plug it in. Make sense? Yeah, okay. Now, Melanie, what's the other number? So I can give you a point. Solve it. You want it to be 0. I'm going to solve it. This is only minus. What is the undo of minus? Positive, to plus 3. Okay, so negative x equal to 3. How do you get rid of negative 1? Divide by negative 1. Yes, x equal to 3 divided by negative 1. Negative 3, very good. So negative 3. Okay, let's give Melanie 1 point. Josma, what's the last number? I want this one to be 1. Help me just solve this. Add 3, right? So negative x equal to 4 divided by negative 1. X is 4 divided by negative 1. 4 divided by negative 1. Negative? Negative 4. Very good. Okay. Now plug it in here. So remember, we purposely chose negative 2 because we know that when you look at negative 2, the whole power equal to negative 1. Right? So this is just negative 1 here. This is going to be 0 here. This is going to be 1 here. Okay? You just set your time to plug it in. And then you have on back plus 1, plus 1, plus 1. 2 to negative 1 is 1 half. 1 half plus 1 is 1.5. This is 2. This is 3. Kind of similar to what we did before. Okay. Negative 2, 1.5 right here. Negative 3, 2, negative 3 and 2. And negative 4 and 3. Negative 4 right here and 3. Okay. So it's going to be like this. Is it decay or growth? Is it going decreasing or increasing? Decreasing. So is it growth or decay? Decay. It's not okay, no question. It's a decay, okay? You think you're going down. Why going down, do you know? Oh, I told you that last time that, decay is when this number going to be less than 1, larger than 0, right? And when it's growth is when b is larger than 1. That's growth. This is 2. Why is still decay? Because of the negative, right? The negative here, that's actually is, if you want to become positive, it's going to be like this. 1/2 x, x plus 3. Make sense? So that's why I just explained to you why this is a decay when the number here is larger than 1. Remember the exponential function is this, right? How do we know when it's growth? How do we know it's decay? Growth is when the b here growth when the b here is larger than 1. And decay when this number here is less than 1, larger than 0. But when you look at this one, the b, oh, okay, by the way, b is the one that have the power x. That's the b, okay? So b here is 2. But you have a decay. But actually, it's not 2. It's actually 1/2 because you have the negative. Okay, so think about this. Because when you make sense of it, you memorize more. Any questions so far? You still with me? Yeah? Hopefully? Okay. All right, let's assemble. Maybe 2 more, but the last one I can do together with you. But this one is easy. All right. 5 minutes, let's go. I'm going to show you where. So you can get point 2. Okay, where's the HA first? Where's the HA? Berlin, where's the HA? I'll show you, remember? The line, horizontal asymptote. How do you know? What does it mean when you're negative 2? Remember I told you? You go down by 2. Okay. Right, so you go down by 2. This is the HA, horizontal asymptote, okay? Now, what number you plug it in? So you're going to get negative 1. What number? Negative 2, right? What number you're going to plug it in? You're going to get 0. Negative 1. What number you plug in? You're going to get? Okay. All right. It's faster than me. Okay, so 3. So I know for sure it's going to be negative 1. Don't worry about the fraction, okay? Fraction is not that bad. So I know for sure the power going to be negative 1, 0, and 1. So that's why I just write like this first. Okay, and then we're going to calculate this. Negative 1, negative 1/2 to negative 1. What does it mean? Yeah, you flip it, right? Negative, you want to flip it to become positive. So actually it's just 3 times 2 minus 2. So 6 minus 2 is 4. All right, next one. Everything to the power 0 is 1. So 3 minus 2 is 1. See, you don't deal with a fraction a lot. This one. So 1/2 to the power 1 is 1/2. 3 times 1/2 is just 3 by 2. Right? 3 by 2 minus 2. Yeah, so 3 by 2 is 1.5. 1.5 minus 2 is negative 0.5. Or negative 1/2. Okay? But again, in the table, maybe this is the only case I recommend you to do the decimal, so it's easy for you to see where is it on the graph. Negative 2 and 4. Negative 2 and 4. Let's say this is 4. Okay? Negative 1, 1. Negative 1, 1. 0 and 1/2. 0, 1/2. Okay? Again, it's go along along with the horizontal asymptote. So you're gonna cut through like this. Yeah? Alright, the lattice symbol we're gonna do together. Okay? Alright, we're gonna do this one together. Oh, I wrote the same thing. My bad. All right, we're going to do this one together, okay? First thing first, where is the horizontal asymptote? What does it mean? Plus 5, what does it mean? Go up 5, go down 5, what? Go up by 5, very good. 1, 2, 3, 4, 5, so go up by 5. Okay, this is the HA. Now, what point you're going to plug it in? So that the power going to be -1. 0, it's not that hard, okay? How about equal to 0, 1? How about the power equal to 1, 2? Yeah? Easy, easy? Now, why I'm going to do this one together? Because it's kind of tricky to do the calculation here. I got a lot of questions asking about whether we do the power first or we multiply the number first. Okay, I'm going to ask you too. This is -1 plus 5. All right. Question. Are we going to multiply -4 and 3 first, or we take care of the power first? Who say we're going to take care of the number first? Like multiply this one first. Right, who say we're going to take care of the power first? Oh, good. Good. Actually, this period you got it. I got that question a lot from the other period. Remember pandas. Panda is what? Parentheses, exponent, and then multiplication. Okay? So don't multiply the number first. You need to take care of the power first. So 3 to the power -1 is 1/3. So -4 by 3 plus 5. I'm going to let the calculation for you, but eventually you're going to get 11/3. Okay? 11/3 is about 3.6. Yeah, 3.6. So it's about 3.666 something. Okay? 1. I know that because I purposely make the power to be 0, so I know this one going to be 0. This one going to be 1. All right, 3 to the power 0 is 1. -4 times 1 is -4. -4 plus 5 is 1. Okay? Here, don't multiply first. You take care of the power first. Again, this one you take care of the power first. You have 3 to the power 1 is 1. No, 3 to the power 1 is 3. 3 times -4 is -12 plus 5 is. Good job, Mr. Parker. Talking to myself. All right. 0 and 3.666. So 0 here, 3.666 maybe right here. 1 and 1, so 1 and 1. 2 and -7, 2 and -7 maybe down here. Okay, so your graph going to be look like this. That's it. Okay. So for sure, if I give this on your final, then I'm going to give you, because final is always multiple choice. I'm going to give you 4 graph and you're going to answer it. Okay.